Okay, so today we're going to do average rate of change. It's my first calculus video, so I hope you really enjoy it. So average rate of change, you can see the formula right here for average rate of change. And I'm going to do my best to explain what average rate of change is, and I'm going to take you through a few examples of how to calculate the average rate of change. And so let's get off. So average rate of change is a measure of change in the dependent variable with respect to a change in the independent variable. A secant is a line crossing a curve, and you can see right here that I have a secant crossing a curve. You can see I've labeled the independent variable and the dependent variable all right there. So average rate of change is short form is AROC, and the formula is right there. It's f of x2 minus f of x1 all over x2 minus x1. And I'll show you how to use this formula and what it sort of means. It's usually measured in meters per second, but it also depends on the question. So let's go to our first example. May and Richard are throwing a frisbee at the beach. When May throws to Richard, the height in meters of the frisbee above the sand after t seconds is described by the function h of t equals negative 2t squared plus 3t plus 1. So find the average upward velocity, average rate of change of the frisbee for the time period from t equals 1 lasting 1 second, 0.5 seconds, 0.1 seconds, 0.05 seconds, 0.01 seconds. So you see here I've calculated the t element of x1 and x2. If you see here that t originally was 1, so x1 would be 1 and lasting for each of these 5 times. So x1 is t equals 1 second, and then you add 1 second here, and then you get 2 seconds. That's our x2. Take a moment to look through these equations and see if you can see what's happening here. I took each of the time lastings and I added them to the original x1. I added the time lasting to x1. And then I got answers for each of them. So it's 2 seconds, 1.5 seconds, 1.1 seconds, 1.05 seconds, and 1.01 seconds. And you can see here that I have the t element of x1 and x2 for each of the times allotted. Okay, question 1. So we have our x1 and our x2, and we're going to calculate it with the formula. I'm going to get the formula here. It's ht So that's our formula here, and we're going to need it to calculate f of x2 and f of x1. So let's calculate f of x2 and f of x1. This is x2. Okay, as you see here, we calculated f of 2 and f of 1, and so it's basically f of x2 and f of x1. So let's plug in these numbers into our formula. So there's our answer here. Our average rate of change is -3 meters per second when the t element of when t element of 1 and 2. Our answer is -3 meters per second. So our t element is 1 and 1.5. Let's calculate f of x2 and f of x1. Okay, let's plug these numbers into our formula. So f of x2 is basically f of 1.5. You can see x2 is right there. So f of 1.5, and we calculated f of 1.5 there, minus f of x1. Our x2 is 1.5 and our x1 is 1, so it's 1.5 minus 1. And as you can see here, f of 1 would be f of 1, and we calculated that right there. And we got our answer. So we have a formula here f of x2 minus f of x1 over x2 minus x1. So we can see our x1 would be 1 and our x2 would be 1.1. So let's plug those in. I'm just calculating f of x2 here. So you can see how we got those numbers. F of 1.1 would be 188. F of 1 would be 2. And it's minus. And our answer is negative 1.2 meters per second. And let's move on. I'll give you a moment just to write that down. And let's move on. x2 and x1 are 1 and 1.05. So we're going to plug those numbers into this formula. If you plug that into your calculator, you'll get 1.945. And as we know, we've calculated this a few times, and the answer is always 2. If you plug this into your calculator, you'll get an answer of negative 1.1 meters per second. Moving on. So we have x1 and x2, that's 1 and 1.01. We're going to plug those numbers into this formula. And we're going to calculate f of x of 2 and f of x of 1, or f of x of 1.01 and f of 1. If you plug this into your calculator, you get negative 1.02 meters per second. So those were a few examples of calculating the average rate of change. I also have some additional practice here. The displacement in meters of a ball rolling in a straight line on a grassy hill is given approximately by s of negative t2 plus 6t plus 5, where t is measured in seconds. So find the average velocity or average rate of change of the following time periods. And they already give you t of element. And they already give you the t in the x of 1 and x2, so you don't have to calculate it. And I have the answers down here. So I'll give you a moment to pause and just write them down if you feel like doing additional practice. And that's everything that we've done today. If you have any questions, feel free to comment. And I hope I explained it well enough to a degree and you could understand what I was doing throughout the questions. But I am here if you need me. So thank you very much for watching my math tutorial video.